So we are here on page 26, and I do want to just refresh your brains with how to do this. So we'll do it a little bit together. What's step one?
Mark them all.
Mark them all. How much? Figure out what the lines are going up by and mark them. How do we figure out what the lines are going up by? You label it, but how? You can just count. Just figure out. You just gotta wing it. They got the 0 labeled. They got the 50. Clearly, we're not going up by ones. There's not 50 lines. Try something higher. So you could try 5s. You could try 10s. You could try 20s. It does go up by 10. 0, 10, 20, 30, 40, 50s labeled. So I labeled every line. Is what I did good enough? No. What's up? Why not? Okay, the other side. Oh, yeah. Don't forget. Kind of remember step 2 as well. Step 2 says you're going to put scrap paper along the line that you're going to profile. Logan. Thanks, dude. So since you're putting your paper here, you want to put your labels where you can see them. And yes, you want to label all the way across. So I'm going to label up here. I want to see all those labels. That is, now it's not a guarantee that you're going to screw up if you don't label them, but if people screw up, it's usually because they didn't label the lines like I just said to label them.
What page are we on?
If only I had said that already or put it on the board, it might be helpful.
27.
26. See how it says take out chapter 2 packet page 26?
Yeah, I do.
That's good to know.
Oh, yeah. Okay.
I'm sorry. Is there really a white circle? Is there really? Yes. I think it.
Okay, so it looks like everybody did just fine labeling in, and most of you went on to the next step, which is to mark every place a contour line touches your scrap paper. I know a lot of you have already done this. I'm going to do it now. So you might see that I kind of do a little shortcut when the lines get super close together. Instead of labeling it 50, I labeled it 5, 4, 3, 2, 1, and 0. I know in my head that that's really 50 and 40 and 30 and 20 and 10, but I don't really need to write that extra 0 to know that. So there are some shortcuts that work, but whatever shortcut you're doing, it better work for you. So those of you who chose not to label them, it's not required, but you will screw up eventually if you don't label them. This one's really easy, so it really won't hurt too bad. Then we're moving on to the next step, which says to put this along the x-axis. And then you are going to use this. You're going to pretend it is glued to the paper and follow your patterns. So the 10, 20, keep going. Don't stop. Do you have to draw these guidelines that I'm doing to make sure I get straight above? You do not. But again, it is really important that your dots are directly above where they're supposed to be.
What if that bottom paper you have, what if you started it more to the right?
That would have been fine too. So there was no, okay, so this one, it did have an A here. But the B did not fit all the way over. On the ones that are for the regents, which I think I have a couple examples in the back of this. Yes, like back here, you were doing a profile from A to B. On their paper, they marked off A to B. In that case, the A goes where the A is and the B will go over on all the way to the B spot. Because of the way I put these in here, I didn't keep the ratio the same. So I just blew up the map to fit half and blew up the graph paper to fit half, but the B didn't, it wasn't supposed to be like that. So on the regents, they'll pretty much tell you where to put A. And this one, if you put it over a little, that's fine. So this was the end of that step. So you had all your dots. Step 5 and 6 say to connect the dots, but don't forget about the hill. What's going on here, which is representing that dot to that dot? What's happening on the inside of that circle? It's going up. How high could it go up to, by the way? 59. Where'd you get that from? One less than what would have been the next line. So 60 would have been the next line. We don't have any 60s because there's no 60 line. So we know that this hill has to go up above 50, but not touching 60. So I usually start at the hill. This case, it's a little hill that does not touch 60. And then you can connect up the rest of your dots, being very careful that your line goes where it's supposed to, unlike mine did a little bit there. That one's pretty easy, right? And we already did this one. Did yours look like mine on page 27? I think we talked about this. Did we talk about how this is a dip here? And the reason I know that's a dip, because if I went into this space in between the two 160s, that space is really between the 140 and the 160 line. So that's a little dip, not a little hill. Then I think we have 2 more to do, don't we? Page 28 and page 29. Before you get started on 28, I want to check that you've labeled your lines correctly. Nope, we're going to start one new thing after this. They do go up by tens. How'd you figure that out? 50 and 100. 50. So again, label it above the line because you're going to put your scrap paper here. You want to be able to see your labels. So there's your 50, 60, 70, 80, 90, 100. So all you have to do to figure out what the lines are going up by, just try a number. Try ones, tries fives, 10s, 20s, 25s, 30s. Something will fit. What is the elevation at E?
9.
How do we know it's not 110?
Because it would be parallel
Parallel to what?
to the other lines.
It is though, isn't it?
100 isn't.
The 100 isn't. Okay, see how that 100 is a circle or a loop, I guess I should say. That's the top of the hill. We talked about this on Friday, how the base of the hill is really wide. So you're going to have a really big base, and then it's going to go up, up, and up until it gets to the smallest point. The way this is drawn, that's the smallest area. So that's the peak of the hill. And then it's going to start going back down. So at E, it's going to only be 90. That's the part I wanted to make sure you got. I'm going to let you try this one page and page 29 on your own. I'm going to come around and check and hover over you, see how you're doing. So this should be what your profile looked like for page 28. Make sure that it started, like when you're doing these, if the directions say go from E to F, make sure you are always going from E to F. So some people turn the paper around sometimes and I'm going F to E. To do that, you would have done it this way. Like you would have almost turned your paper upside down and gone this way. Make sure you're always doing what they ask you, E to F. On the next page, yes, this was just a little guy down here at the bottom. Saw a couple of mistakes that were very common this period and last period. First, people saw that this graph was going up by 20. Does that mean that the lines go up by 20? No, it really just meant that I reused the same graphic that I made here, and I used it here. The Regents will also do things like that to mess with you. They might label every 20, But then you guys know that what's halfway between 0 and 20? 10. So do not looking here to see what these numbers go up by was never a direction. You look at what's labeled up here, 0 and 60. The other mistake that a whole bunch of you kind of asked me about while you were doing this. So when you're walking along this line, do you ever touch the 60 line? No, again, that was there to mess with your brain. This line never touched the 60 line. So don't just assume because there is a 60 line that you're going to walk on it and need to draw that profile. So again, this should look like this. 2 dots somewhere in between 40 and 60 to mark off 50. The little hill on the top that does not touch 60. Do some of you need some more time to finish up 29? Okay. So we have one more thing to learn. Let me refresh your memory on the things that you'll have to do. First, you are going to be asked to draw the lines, connect the dots. That's one thing that you have to do. Remember, these guys were harder than any of the regions will ask you to do. Then you need to be able to answer any questions that went along with this page. So you'll have to be able to tell me how far apart 2 points are. You'll have to tell me what the lines go up by. And not only that, if I put a dot right here and labeled it A, could you tell me the elevation at that point? In fact, that's a question. I want to know what the elevation is at A. Could be like 10. How'd you figure that out? Because it's in between 0 and 20. So does it have to be 10?
19.
It could be 19. It could be 1 because it's between the 0 and the 20. So in other words, A is anything between 0 and 20 as long as it's not 0 and not 20. So 1 through 19.
What if you said it was like 0.1?
0.1 would work as long as you make sure that point. So technically also would 19.9999999. But let's just stick with 19. Anyway, so you have to be able to do that. You got to be able to tell me which way the stream is flowing and how you know. So there's 2 ways. First of all, rivers always flow downhill. So you can see which one's the highest elevation and which one's the lowest. Or you look at these bends the contour makes. The contour lines will always make like a V or a bend, and the water will come out of the V. You have to be able to tell me that why this side's the steep side. Because lines are close together. And why this side's the gentle side? Lines are far apart. You'll have to tell me the highest possible elevation inside this circle. In fact, what is the highest possible inside this circle? Careful, remember they're going up by 20s. So 139. So you go to what would be the next line. So 140 and subtract 1. Then they're going to ask you to do the profile stuff. And then they're going to ask you one more thing, and that's on page 30. The last thing that they're going to ask you to do is to calculate gradient. This is going to be the steps for steps 2, I guess, calculate gradient. But what the heck is gradient? Gradient is one of those fancy earth science words. Yeah, do you know what gradient means? Does it have to be go down? Could be up. What is this and this talking about? What? Not
Slope.
slope. Also in in art class, if you looked at the color gradient, you would have darker colors to lighter colors. But in this case, it is just the slope or the steepness. So yes, it is how much it goes down or how much it goes up. It's the slope of the hill. And it is going to be the average. It's not going to be at every little point on the hill. This is going to be the average. So when you hear the word calculate, what do you start thinking about?
Math.
Math. Oh boy. That's all right. It's fine. We're talking math here. Math and science, they go hand in hand, but nobody likes it. There are some good things about math in this class. Do you guys remember what some of the good things are about math in this class?
It's on here.
It's on here, and by on here,
Or reference table.
your Earth Science Reference Table or your ESRT. You do not have to memorize formulas ever. So we got the formula. It says change in field value divided by distance. We have to talk about that phrase field value. If you remember, a field is whatever you're measuring. So this room could be a field. This map is a field. Whatever you're looking at, that's the field. So we're talking about a change in field value. So it's just a change in whatever the heck you're measuring. So if you're measuring elevation, it's a change in elevation. If you're measuring temperature, it's a change in temperature, etc. And distance is just how far apart 2 points are. If you can just wing it using that formula, you're welcome to. But I know many of my students are not just like wing it in math class people. So I have set up 5 very simple steps to follow that if you do these 5 steps, you cannot get this question or these questions wrong. So just for this one time, and that's all we're doing for the rest of the period, is writing these notes and doing one example. So if you could stick with me for this, and you have no homework, so there's really nothing else for you to do right now. Let's write in the 5 steps for calculating gradient. First thing, I don't know why I gave you 6 boxes. So cross off that bottom box. We are not using it. We're going to start off with step 1. Step 1 might sound familiar because step 1 is determine the contour interval and write it in for each line. So determine the contour interval and write it in for each line. Does that sound familiar? It's legit the same first step as drawing profiles, which works out because usually if they have you draw a profile, the very next question will be calculate the gradient. So if you've already done step 1, you don't have to do it again. Step 2, calculate the difference between the 2 points. Hey, by the way, when they say difference in math, what math are you mathing? Subtraction. Oops, you gotta be able to spell subtraction. Wow, not ST. Where are you going with this, Mrs. Ritz? Subtract. So really, you're just subtracting the values of the 2 points. Step 3, measure the distance between the 2 points. How will we measure the distance between 2 points using a map?
The scale. Yeah.
Use the map scale. the map scale, I'm gonna add this up here. I don't know if you guys have some room for it. Remember, distance is either going to be in miles or kilometers. Step 4. Write the formula for gradient. Which that is straight off your reference table. Gradient equals change in field value divided by distance. Did we already calculate the change of field value in any of these steps?
They calculate the difference between the 2 points.
This is really saying take your step 2. And did we already calculate the distance or figure out the distance? So we're really just taking step 2 and dividing it by step 3. This seems super long, but it's all just doing math. It's just the steps for solving an equation. And by the way, steps 5, solve. I just did. I went with an L.
Yeah, I did
SL. It's just because that's what happens when your hand works faster than your brain. So let's give this a whirl. This is the last thing we're going to do all period. Before we get started, I want you to see A is right here. What is the value for A? 100. B, the dot for B should be under the letter B. It is not on the 250 line. On the regions, that'd be super clear. That wouldn't be this tiny little graph or mark. Oh, you're not supposed to know that yet. You guys see, this is how fast most of you will be able to do this, much faster than I'm taking it. What's step 1 tell us to do? Figure out what the lines go up by and label them. So we've got 100 labeled and 250 labeled. They're going up by 50s. How do you figure that out? Just try numbers. They're not 10 doesn't work, 20 doesn't work, but 50s do. So 150, 200, and then 250 is, yeah, it is. I don't know if I want to say common sense, but it's not difficult to figure out what they go up by. Is there any work to show for step 1? No, there's no work to show for step 1. Step 2 said calculate the difference. Again, that's subtract. So we take B minus A. And yes, for this one time, can you just write all of this out? So what was the value for B? 200, which we know is super easy because we already labeled it. And A is 100. So what's the difference? 100. Ooh, what's the label on those, by the way? So this hill goes up to 250 miles in the sky?
No.
Scale says miles. Are we using the scale right now? So if you recall back when we did the notes here on page 23, these are only going to be in meters and feet. How do we know which one it is? If the scale's in miles, then these are in feet. So this is feet. If the scale was in kilometers, those would be in meters. Now we got to figure out how to measure the distance between the 2 points using the map scale. Here's where I've seen all sorts of interesting ways of doing this. I'm going to throw your pencils across the room if I see people trying to tell me like this, using your pen tip. I've also seen plenty of people try to use their fingertip to tell me how far apart they are. I've also seen people mark the scale on their papers. This in theory would work, but it leaves you an extra step for making a mistake. I recommend taking your scrap paper and just putting a mark for B and a mark for A. And then taking that down to the scale. And to me, it looks like it was exactly 1, maybe a tiny bit off of the 1, but not enough to count. Everybody agree with me? Carson, you good?
Yeah, I think, yeah,
You sure? Because you double checked. I wanted to make sure.
yeah, it's close, it's like really close.
It is really close. So if you want to call it 1.1, you can. I'm going to call it 1
I'll call it 1, not good.
1 mile. Step 4 does say to write the formula. Will you always have to write the formula? Probably not, but I just want you to for here. If you do want to shorten it up, you can just call it change over distance. And then step 5, I just want you plug, and remember this is, so let's add it here one time. This is really just step 2 divided by step 3. So step 2 was 100 feet divided by step 3, which was 1 mile. So not feet on the bottom.
Miles.
What are the units? So by the way, you should use a calculator. I'm hoping most of you know that 100 divided by 1 is 100, but please don't trust your brain for any other math. Use a calculator. What are the units?
Oh, yes.
Feet over miles, which is what you just said, Carson, the elevation divided by the distance. So that you can do it with a slanty line like that. You can do it like this. It's whatever these are. So if it's in meters and kilometers, then it would be meters per kilometer. But in this case, it's feet per mile. What this means is if you were to take this path from step A or point A to point B, you would be walking on average, you'd be going up 100 feet for every mile you were walking. That's a very steep hill, by the way. All right, that's as far as we're going to get for today, and no homework tonight.